First couple problems, just watch, and you can, I'll be asking questions like I always do, and feel free to jump in and answer along with me. And then I'll hand it over to the class, and I'll call on people. And as always, if you don't feel like answering, you don't have to. Just but remember that there's no judgment. We're all just trying to learn all this stuff. Okay, so the first couple of questions involve inverses. And this one says, determine whether an inverse exists for the following function. There'll be one almost just like this on the test. And if an inverse does exist, graph the inverse. And if it doesn't exist, place an X over the graph. So this first one is a parabola. So will it have an inverse function? Yes or no? Feel free to chime in if you want to. And why or why not? So the answer to that is this will not have an inverse function. Get this up to right. Because
it has 2x values.
That's right. Well, not the X values.
I'm sorry, Y values.
Right, there you go.
Yeah.
And the test that you could use is called the horizontal line test. So it fails the horizontal line test. So we put an X over that. Now this one will have an inverse. It passes the horizontal line test. And to graph an inverse, the way that is easy to do it is just to pick some points, some key points like 0, -3. This one looks like about 1, 0. I'm just guessing here. This one looks like it's about 2, 2. Okay, and then to graph that, we switch the X and the Y. So on the inverse function, it will be -3, 0, 0, 1, and 2, 2.
I graded 5.2, and it seemed like a lot of them were getting the point switches, but they weren't getting the switching the asymptote thing, and they drew the graph a little bit wrong. Yeah.
Okay, well, I may have one like that on here. So we have -3, 0, 0, 1, and 2, 2. And so the inverse would look like that. And something that's cool about a function and its inverse is that the two will always be symmetric with respect to the line y equals x. So the line y equals x is like 1, 1, 2, 2, 3, 3, 0, 0. So if you drew the line y equals x and folded the graph over on top of that line, it would exactly fold over on top of itself. Okay, so I would like y'all to do number 19 and 20 or whatever the numbers are on these. Take a minute and do those.
They did really well at solving it symbolically, though.
Oh, that's great.
Yeah, and it had like a dividing by a binomial thing in there. It was a little tricky. I don't think we had one like that.
That's great. How'd they do, like, if they had the variable on the bottom, you know what I'm saying?
1 over x sort of thing.
Yeah.
+5, and then you have to swap it and like divide by a binomial. Yeah, they did really well with that. I was just
good.
Most of them nailed it.
Good.
I'm trying to think if anybody missed it. I think everyone got that submitted homework. But like with that said, like there's some people that are like not submitting homework now. Like,
Right.
I feel like some people are kind of getting off track and not doing what they need to do. I don't know. And right now is a really bad time to do that. Like, you have done really, really well, or pretty well in this class so far. If you're still in this class, most of you are like either well passing or like right there on the line. And like, don't slack off these last 2 weeks or 3 weeks, whatever we got left. Like, it is so important to stay on it these last couple of weeks. It really is. I can't emphasize that enough.
Yep. It's kind of like we're at the end of the marathon and you just got to hang in there a little bit longer, even though you're
I know
tired.
that, yeah, the fatigue is definitely probably setting in at this point. And we always see it, like right here. Don't do that to yourself. Keep it hard. Keep going. Y'all are doing great. Just keep it.
You are.
Appreciate it.
I'm proud of you guys. Really, it's a huge commitment to be in this class. Okay, so we may not have finished this. I'll give you a couple more minutes. But what about the circle? What would we say about that one? Does it have an inverse function?
No.
No. And it doesn't have one because there's a couple things you could say that would be correct.
Doesn't pass the vertical line test.
Doesn't pass the horizontal line test.
Horizontal.
Actually, it's
sorry.
not even a function. You're exactly right. It doesn't pass the vertical line test either. So it's not a function at all.
Awesome.
So it doesn't pass the vertical line test, nor does it pass the horizontal line test. So you're exactly right. But when we're talking about inverse functions, we're looking at the horizontal line test. Normally, and I wouldn't give you a circle because that's not even a function. So what about number 19?
It is a function.
It is a function, yes. Why? It has an inverse function.
Right.
Why does it have an inverse function?
Because does it pass through the horizontal line?
Yes. And then I think Timothy or somebody told me earlier, you could also say because the y values do not repeat, or there aren't.
Yep.
So how would you graph the inverse? What would be just give me like 2 points that would be on the inverse function.
I got like 1, 1 and 2, -3. I'm sorry, yeah, yes, for the inverses. Well, 1,
so
1, you can switch those around either way. There's still 1, 1.
You
and,
mean, so I don't see, are we looking at 19? I don't see
Yeah.
1, 1 on this graph.
I see
Sorry,
0,
1, 0.
1.
Oh, there you
0,
go.
1.
Got it.
Damn,
So
my
0,
bad.
1 would be the same. So what would the point be that goes with 0, 1?
1, 0.
1, 0.
Yeah, Gabriella had it right. My bad.
Yeah, and then what's another point?
I put 2, -3.
2, -3.
And
So
to inverse it would be -3, 2.
that looks good. Yes. So 2, -3 looks like it's on the graph. So that means that -3, 2 would be on the graph as well. And
Can we like pick any points for
you
the
surely
test?
may. Now, if you have a graph, and just like if you had something like this one right here, you would probably want to pick like here, if it was half of this, for example, you would probably want to pick enough points to where you could actually draw the shape. You know what I'm saying? These are lines, so you really only need to pick 2 points. But if it was some other shape, you'd probably want to pick enough points that would give you the shape you're looking for. So like if we're looking at this half of a parabola, and I was going to graph the inverse, I would pick this point, and this point, and take and switch the X and Y and graph those 3. So Like this one is negative 1, 0. So 0, negative 1. This one is 0, 1. So 1, 0, 1. So 1, 0. And this one would be 1, 3. 1, 2, 3, 4. So then 1, 2, 3, 4, 1. So it would look something like that. And you'd want to, that's what you just want to pick enough to where you get the general shape of the graph. Okay. So on this one, so this is combining functions. And remember that if you have f plus g of 1, that's like saying f of 1 plus g of 1. And f of 1 is 1, 2, 3, 4. And g of 1 is 2. So 4 plus 2 would be 6. So remember, when you're looking for the f plus g of 1, that's just f of 1 plus g of 1. You go over to 1 on the x and then rise till you hit the f function and pick whatever the y value is. That's what goes here. And then you do the same for the g. Now here on this next one, g of f of negative 1, that is the same thing as g of f of negative 1. And remember, what that means is you start with the innermost function. So we're going to find f of negative 1. So I go to negative 1 and look on the f function. So what is f of negative 1?
Zero.
Yes,
Zero,
it's
oh.
the right. So that this is going to become g of 0. And so now I go to 0 and I match it to its point on the g function. And what is that value going to be? It'll be 3, right? So I'm looking at g of 0, and that is 3. And that's going to be my final answer. Now, when I'm talking about an inverse function, what this is saying, I'm looking on the g graph, and I'm looking for where the y value is 3. And my question is, what's the x value? So I go to 3 on the y-axis, and I match it with the g graph. And so the point right here would be 0, 3. So what is the inverse g negative 1 of 3? Because we're starting with the y and we're finding the x anytime we have that negative 1 in there. So we started with 3, and the x value that is attached to it would be 0. So g negative 1 of 3 is 0. And then this last one says f of g negative 1 of 3. Well, we just found g negative 1 of 3 is 0. So now I'm looking at for f of 0. So I go to 0 and match it with the f function, and that would be 1. Okay, so take a couple of minutes and try these, the ones on the do part of the review. Whoops. Okay, Timothy, will you help me with this one?
Sure.
What's f plus g of -2?
F of -2 is going to be 1 plus g of -2. It's going to be 1, 2, 3, 4. 4. So it's going to be 1 plus 4
Uh-huh.
equals 5. I'm sorry.
Yep.
Yeah.
Perfect.
Yeah.
Okay, what about
F-
b?
G of 0. What would that is? Be 0.
Okay, which one do you find first, g or f of
Well,
0?
you find f of 0 first. So it'd be
Okay.
0, 1.
Okay, f of 0 is what?
1.
1, right. And then what's g of 1?
1, 2, 3.
G of 1 is,
I'm sorry, G of 1, my bad. G of 1 is 2.
yes. And I
Sorry.
know it's confusing sometimes because you're looking at two different graphs, so you have to make sure you're going to the right one every time.
Exactly.
Yeah, right.
And double check.
Uh-huh. So what about g -1 of 2?
That would be the inverse of 2. So
Mhm.
G of 2. So, okay, let me write this out. -2 is 1. So 1 -2 inverse of that would be
Okay, it's 2, not -2 though.
2. Right.
Yeah, it's just 2, right?
So 1, 2 inverse of that would be -1, 2. So,
Okay, so first of all, g -1 of 2. Okay, so so what we're actually looking at is the point on the g function where the y value is 2, right?
yes.
So you're going to go to y, on the y, and find where it's equal to 2, and then match it to the g function.
Which would be 1, 2.
That would be 1, 2, right? So
we
what is g -1, 2?
G negative.
What's the x value there, in other words?
1.
1, right. So you're just doing it backwards. It's like usually we're used to them giving us the x value and we match it to the y value. Now they're giving us the y value and wanting us to match it to the x value. All right, and finally, this last one is f of g -1, 2. So we said f of g -1, 2 is what? Did we say it was?
It was 1.
1. And what is f of
I
1?
said it was 1.
Yeah.
And f of 1 is 2.
Yes. Good. Thank you, Timothy.
You're welcome.
Okay, so then we are and just FYI, I did this on the test as well. So be watching for this. First of all, I'm going to have a multiplication problem, 9x squared minus 81 over x squared times x squared plus 9 over 9x minus 27. When you have a multiplication or division problem, remember that these are really easier than the addition or subtraction. It's just going to be top times top over bottom times bottom, but first factor. So 9x squared minus 81, you can factor out a 9. And you can factor out a 9 here as well. X squared plus 9 will not factor, but x squared minus 9 will. It will factor to be x minus 3, x plus 3. And now we have to do is start canceling common factors. So I can cancel this 9 with this 9, this x minus 3 with this x minus 3. And what I'm left with is x plus 3 times x squared plus 9 over x squared. Will anything else cancel? The answer to that would be no. All right, now, because I'm a kind person, don't want you to have to be doing too much repetition of things.
Question.
Yes, yes, ma'am.
So we don't factor x squared plus 9 because it's prime.
Plus, yes, it's got a plus in between it. So in order to factor that, we'd have to use imaginary numbers. And we're only in this section, we're only working with real numbers.
Oh.
You're not going to have any i's. So in other words, if you have a squared minus b squared in this section, that'll always factor to be a minus b, a plus b. But if you have a squared plus b squared, that's always going to be prime. That's exactly right. Did that answer your question?
Yes, thank you.
Okay. All right, so here on this one, if you notice, what I would always do when you're doing division is always first flip the second fraction. So here I have 9x squared before you do anything. And some people don't like to do that, but if you don't, I guarantee you're gonna cause yourself more work than you want. And then if you notice, what do you notice about this compared with this? They are the same problem. So don't redo all the work. I know it's going to turn out to be the same, right? You might want to redo the work just to check yourself. But if you remember to take the reciprocal of the second fraction first, you could save yourself a lot of work. Okay, so I want y'all to do these two right now. Aurora, did you get the first part?
Can I volunteer to do it?
Absolutely.
So for the top left one, it is 4 parentheses x squared minus 36.
Mm-hmm.
And then below on the left, it stays the same.
Yep, because that's prime, just like what Aurora was saying earlier.
Mm-hmm. And then the top right is 4 parentheses x squared plus 1.
Mhm.
And then the last one is 6 parentheses x minus 6.
Yep.
Then this is when you start canceling stuff out.
Okay, you're correct, except for there's one last thing you can factor. Do you see it?
No.
Look, what about x squared minus 36?
I'm not too sure about that.
Remember that a squared minus b squared, if it's got a minus between two perfect squares, it will always factor to be a minus b
Oh, is it
times a
gonna
plus
be
b.
x minus 6
Uh-huh.
and x plus 3? I mean plus
Right,
6.
right. So this will factor to be x minus 6 times x plus 6. Do you see that, Elliot?
Oh yeah,
Yeah,
I
yeah.
see that.
So kind of just watch that. Now the x squareds plus ones will not, even though they're perfect squares, but there's a plus between them, so they won't factor. But that x squared minus 36 will. Okay. So now what? Now start canceling stuff.
Okay, so cancel out the x minus 6.
Mhm.
Cancel out the x squared plus 1.
Good. Yes.
And I don't think you ever cancel out like the two top ones, right? If they're the same.
No, that's correct.
Yeah. Then you would just multiply the top.
Okay. And what would you get?
You would get 16 over 6.
And what else is on top?
Oh, I didn't see that. X parentheses x plus 6.
Yes. And it's super easy to, you get so much scratching out going on. It's easy to forget something. So always go back and make sure you check your work. Okay. So is there anything else I can do to this?
No.
Okay. Is 16 and 6, they both have what common factor? What do they both have that will divide into them?
Two.
Uh-huh. So I can divide 2 into both 16 and to 6, right? So that's going to give me 8 times x plus 6 divided by 3. Because 16 over 6 reduces to 8 over 3. So it really is quite a bit going on in these problems because you're factoring, you're canceling, you're reducing. So there's a bunch of steps that you have to really watch out for. And partial credit is given all throughout, but it's always nice to get full credit on something. So make sure you go back and check your work. Okay, what about this division problem? What happens here? What's the first thing you would do, Elliot?
You would flip the second one,
Right.
second fraction, and it would give you the same answer as the.
Yeah, it gives us the same problem. Now, that's not necessarily going to happen. I mean, of course, it doesn't happen all the time, but on this test, it will happen. So be careful. If you'll know to flip the second fraction, then you're in good shape because then you have the same answer as the multiplication problem. Because the only difference between multiplication and division is that with division, you reciprocate the second fraction, and then you do it exactly the same. All right, so then part C, on these, the first thing you always want to do is get a common denominator. Then you keep the denominator and combine the numerators. And then you simplify. Okay, so here, x squared minus 25, we love the difference of perfect squares in this class because they're easy to factor if you recognize the pattern. So x squared minus 25 will factor to be x minus 5 times x plus 5. And then the denominator of this second fraction is x minus 5. So what is the lowest common denominator of this problem?
X minus x plus 5.
Yes. So that's our lowest common denominator. So now notice there is no equal sign in this problem. So to me, these addition and subtraction of rational expressions are the hardest thing we do because you can't get rid of the fractions. You have to keep the fractions. When we get to the equations, then we can multiply through and get rid of the fractions, which is always really nice. But in this case, we can't because there's no equal sign. So I write 5x over x minus 5 times x plus 5. That one already has the denominator we need. Minus 2, I'll do a different color. Two over x minus 5. And what do I have to multiply the numerator and the denominator of this second fraction by in order to get the denominator I need?
X plus 5.
Yes. Once we have the common denominator, we keep the denominator. And we combine the numerators. Now here's where you got to be careful with the subtraction. So this is going to be 5x, and I'm distributing the -2. This is where people mess up. So this is going to be minus 2x minus 10. And then I just combine the 5x and the 2x in the numerator. And that's my final answer. Okay, so I want y'all to do this one.
So I realized I messed up on something in the notes in 5.1 with the domain of the composition of functions. And I don't think it's going to be a big deal because I don't think there's anything like that. But I think I said it's going to inherit the restriction from both of them, but it only inherits the restriction from one of them.
In a composition, it depends,
Yeah.
right?
You have to look, well, it inherits it from the first one you plug it into, and then you have
Yeah.
to look at the result afterwards.
Right.
But I said it inherits it from both of them, and it doesn't. And I made a little note on the video if they want to go back and look at my explanation.
Yeah, that's not going to be a
But, like,
problem on this
Yeah,
test,
it's
though.
it's a little tricky, and it's a little something. When I did it,
Yeah.
I was like, that doesn't seem right. in
Right,
my
it
head.
is.
And then I looked back and went back at it and checked it, and it's like, no, you can plug that in. That'll be okay. It's
Yeah,
like,
I've done that before too. Yeah.
yeah, there's no keys for these.
I know. Yeah. Yeah. You
Anything.
have to. Yeah, I know.
It's like, I hope I'm getting this right. Yeah, I think we're allowed to get like one thing wrong every once in a while, though.
I think we are. I was co-teaching with one of the calculus professors one time, and she and I got in this huge argument, and I knew I was right, but she was just convinced. I mean, absolutely. She says, I've been teaching advanced calculus for years. I know what I'm talking about. And finally I got a textbook out and showed her. I said, no, look, and it was something, something along those, that line. Okay, so who would like to help me with this one?
I can do it.
Okay, great. Thank you.
Okay, so now first we need to factor the left fraction,
Mhm.
which will get you x plus 6, x minus 6 in the denominator.
Yep.
Minus 5x over x minus 6.
Okay.
And then the fraction on the right needs x plus 6 in its denominator to have
Okay.
a common denominator. So we'll
Yep.
multiply both parts of that fraction by x plus 6.
Yep.
And then it'll be 3 minus 5x parentheses x plus 6 over x plus 6 times x minus 6. And then that will distribute to 3 minus 5x squared minus 30x over x plus 6, x minus 6. And then we can write it in descending order of powers of x as negative 5x squared minus 30x plus 3.
Great. We got it. So you get a common denominator. Once you've done that, you keep the denominator, combine the numerators, and then you simplify. Okay. This one is very similar, except for notice that we have the equal sign. And if we have this equal sign, that means we're going to get rid of the fractions. But still, the first thing we want to do is to factor anything that we have in the problem. And then find the common denominator. And then multiply all the parts by the common denominator. And you've done it right, the fractions should go away. And then just solve the problem like regular. So this turns out to be 2 over x minus 1. And 1 is just the same thing as 1 over 1 equals to 4 over x minus 1 times x plus 1. So just like before, we find the common denominator. In this case, the common denominator is x minus 1, x plus 1. So I'm going to multiply every single piece by that common denominator. And do y'all see what I did wrong? I do not know why I did that because I'm a goofball sometimes.
It's okay. I was going to ask about that.
It's like, what are you doing, Mrs. Watson? Okay, so that's this, and this should be, whoops. Okay, did I totally confuse everybody there? Let's see here. Let me do that over. Sorry. Let's start over here. Okay, so this would be 2 over x minus 1 times x minus 1 times x plus 1 plus 1 over 1 times x minus 1 times x plus 1 equals 4 over x minus 1 times x plus 1 times x minus 1 times x plus 1. So you're just multiplying everything, every single part by the lowest common denominator. And in this case, the x minus 1s will cancel. And so that's going to leave us with 2 times x plus 1. Nothing will cancel here. So that's plus x minus 1 times x plus 1 equals to, everything cancels here, 4. Now I'm going to simplify this. So I have 2x plus 2. If I FOIL this out or just recognize this as product and difference of sum and difference of x minus 1, x plus 1 is just going to be x squared minus 1 equals to 4. I'm going to set the whole thing equal to 0 because it's quadratic. X squared plus 2x, and that would be plus 1, and then that would be minus 3 equals 0. And this is going to factor. I need two numbers that multiply to -3 and at the same time add back to 2. So that would be +3 and -1. And then I set those equal to 0. This is probably most steps of any of the problems. And I get x equals -3 or x equals to 1. Okay, now if you go back and remember the domain here is x can't equal to 1 and x cannot equal to -1. So we're going to have to throw this one out because it does not satisfy the domain of the function. So the only solution is x equals to -3. So this has a whole bunch of stuff going on. You have to first find the common denominator, multiply everything through the common denominator with the common denominator, simplify it, and then solve the problem, which if you've got if it's quadratic, that means you have to set it equal to 0 and factor it, set the factors equal to 0, and then make sure you check your answers because they may or may not be in the domain of the function or the equation. So I want y'all to try this one. Aurora, can you help me with this one?
I got a little stuck on
Okay, so did you factor first?
how would I factor the x squared plus x?
Okay, that always, and don't feel alone, because that is always what messes people up, because they forget, and it's easy to do because we're so used to doing all these other quadratics. Does it have a common factor, lowest common factor in x squared and x? Is there something you could factor out of both x squared and x?
1x?
Yes. That's, for some reason, people get hung up on that one all the time. So, and I think it's because it's quadratic, and you're like, oh, well, I'm used to having quadratics have two sets of parentheses or factoring to be the sum and difference of squares, and that doesn't do either one. You just factor out the x.
I get confused on leaving that one behind in the parentheses.
Say that again.
I think I just got confused of leaving the 1 behind in the
Yeah. Yeah. And that's a common mistake. Okay, so what is the common denominator here?
x plus 1.
Right. Okay, so I'm going to multiply every single part by that, right? See if I can do this right this time. Okay, now what?
Now we have just the x and x plus 1 canceling out, and
Uh-huh.
and 2x.
Mhm.
Another 2x.
We're going to take that 2x times x plus 1, right?
Okay.
We're just multiplying this straight across. So, and then plus what?
The LC
Uh-huh. The x's cancel, right? So what are you left with?
x plus 1.
X plus 1, right? I know there's a lot to this one. Okay, so what we have is 1 equals to 2x squared plus 2x plus x plus 1. So now what?
Combine.
Mm-hmm. So we'll
So
have 2x squared plus 3x, right? Plus 1 equals 1.
and we subtract 1.
Mm-hmm. Because it's quadratic, we want to set it equal to 0. Now what?
So guess we just pull out an x.
Right. The only thing we can do is pull out an x, exactly. So what are our solutions?
X equals 0. Minus 2 over 3.
Negative 3 over 2, right?
Oh yeah.
Okay. So we're almost through, but what's the last thing we have to do?
Plug it in.
Check it, right? So what is the domain of this original function? What can x not equal to?
-1 is
Uh-huh. And what else?
and 0.
0, exactly. Because those would both give you 0 denominators, right? So those are not allowed. So we're going to have to scratch out this guy. And we're left with that one. That happens a whole lot when you're solving quadratic equations that evolved from simplifying rational expressions. So you always want to make sure you check your work because that happens a lot. Okay, so then let's look at this. Suppose the population of a species of fish is modeled by this function where x is greater than or equal to 0 in years, which would make sense since you're not going to go backwards in years. What is the horizontal asymptote? So we have f of x equals to x plus 10 over 0.5 x squared plus 1. And how do we determine the horizontal asymptote? What are we looking at?
The powers of x.
The powers of x, right. So in this case, I have an x to the first power. And in this case, I have an x to the second power. So if the power of x in the numerator is smaller than the power of x in the denominator, what does that mean for the horizontal asymptote?
It's 0.
Right. It's y equals 0, right? Don't just put 0. If you put just 0, then you'll get it wrong because it's an asymptote is a line and you have to indicate if it's x or y or something else. Okay, so what does that mean? What does that mean?
It means it'll never cross or touch 0.
Right, but it's going to get really close to it, right? So as time goes by, what happens to the fish population? Is it getting bigger or is it getting smaller?
Closer to 0, so small.
Right, right. Okay, so as your years go by, the fish population is getting really close to 0. So that's. So determine when the population will be 4,000 fish. So what am I going to do with the equation to find out when the population will be 4,000 fish? There's only two things you could do. You could either plug in 4 for x, or you could set the equation equal to 4. Which of these two makes sense for that question?
Set it equal to 4 because
Right,
x
set it equal to 4 because x represents the years, and they're asking you for when the number of fish is going to be 4,000, right? So you're going to set that equal to 4. Now, if you have one fraction equal to one fraction, what is the easiest way to solve a rational function or rational equation?
Multiply by the common denominator.
That's exactly, you can multiply it by the common denominator, absolutely. And if you've got a ratio going on like this one is, or proportion or whatever, if you've got one fraction equal to one fraction, you can always use a cross product, right? That only works if you've got one fraction equal to one fraction. So you couldn't do it, you couldn't have done it here because we have a fraction plus a number equals a fraction. But here we have one fraction equal one fraction. So that's going to give me 4 times 0.5x squared, which would be 2x squared, plus 4 times 1 is 4, equals x plus 10. And then I'm going to set that equal to 0. So I have 2x squared minus x plus 6, minus 6, sorry. See, will this factor? And on the test, I'm not going to give you something hard to factor on this type of problem. 3 and 2. That would be minus. So that's how that factors. You could have factored it any way you wanted, or you could use quadratic formula if you wanted to do that too. So here we'd get x equals -3/2, which makes no sense whatsoever because you're not going to have -1.5 years because time does not go backwards unless you're in some kind of science fiction movie. And here your x equals to 2. So the answer would be after, what's the question? In 2 years. And I realized this question after I wrote it or copied it out of a textbook that it just was really ugly. So I changed it. So this is the one I want y'all to do. A rare species of insect, I don't know what kind of insect it is, but it's very rare, was discovered in the rainforest of Costa Rica. Environmentalists transplant the insect into a protected area. The population of insect T months after being transplanted, and I decided I could make up whatever I wanted since we don't have any idea what kind of insect this is 50x over x plus 15. I would actually want y'all to start with these two, find the horizontal asymptote first and interpret it. And then lastly, answer when will there be 20 insects. So try that.
How did that Superman time travel work? It's like
What?
that's where my brain went for a minute. It's like he flew around the Earth really quick and it like travels back in time. Is it like is he going past the speed of light? Is that the thing he's doing?
Something like that.
Or is it like it's not a gravitational thing because it's like time differs depending where you are, like on a gravitational field too. Like if you're closer to Earth or closer to gravity, time moves slower than like out in space, I want to say.
You think that the Superman people knew that? I guess they do, maybe.
Yeah, I mean they were really playing on some like theoretical like
Pretty good science.
yeah, they were like playing on some like physics sort of stuff that was happening at the time, I think.
Huh.
Sci-fi really, like, I don't know, some of it really does kind of advance science sometimes. I
Oh
think.
my gosh. It's crazy to me sometimes when you read back like Jules Verne's and some of these science fiction writers, how much of it is just like
Or all the Star Trek
they predicted it. Yeah.
So now we
It's
have
like if you can think about it, it can happen.
You should
Okay,
research.
now we're going to be running out of time here. So what's the horizontal asymptote on this one? Anybody? not what equals 50. Remember, it has to be an equation.
Sorry, y equals 50.
Y equals 50, right? Don't just put 50 or you will not get full credit for it. So what does that mean in relationship to this problem? What's happening with the insect population as the months go by?
It will never go over 50.
Right, it's going to get real close to 50, right? You can, and when you interpret it, if, you know, these are my words, but you can use your own words just as long as they're right. Just 50 insects. There's no. Okay, so so close to 50, because I didn't say thousands or anything in this problem, so it's just, this must be just like a really elite rare species. There are not going to be very many of them. So it'll get really close to 50. It will never cross 50. It's just going to get really close to 50. So when will they be 20 insects, and how would I figure that out? There's two things that can happen, and which one would make sense? I can either plug 20 in for X, or I can set the equation equal to 20. Which one would make sense in this scenario?
Plug 20 into X.
Okay, so if I plug 20 in for X, X represents
Oh, sorry.
the number of months. And I really should have put T. X is the number of months. And we're talking about when are there going to be 20 insects. And so we're trying to find what the X is, right? So we're going to say 50, and it really should be T. Okay. And then in this case, since we've got one fraction equaling one fraction, we can use a cross product. So it would take 10 months for the population of the insects to reach 20. Okay, so be careful with some of these. Matthew told me, as he read my test, he said, make sure to emphasize this. So make sure that you're paying attention right now so that you don't mess up. This first one, if I ask you for the domain and all the asymptotes, remember for the domain, you always set the denominator not equal to 0, or you can set it equal to 0, but remember that that's what the number that it can't be. So I'm going to say the domain would be 7x minus 9 does not equal 0. So that means x does not equal to 9/7. So that's my domain. Then the asymptotes. So what I would normally do is find the horizontal asymptote first. In this case. So to find the horizontal asymptote, I compare the degrees in the numerator and the denominator. So what is the horizontal asymptote in this problem? Since the degree in the numerator is the same as the degree in the denominator.
9/7.
Yes, what equals 9/7?
Y.
Y. Good. And that is totally coincidental that these two things are the same. Okay, that and this, that's totally a coincidence. So now to find the vertical asymptotes, we have to factor, make sure everything is factored. So that's going to give me 3 times x plus 4 over 7x minus 9. Will anything cancel? If nothing will cancel, then don't worry about it. If something will, then you want to cancel it. And if something cancels, that's not going to be a vertical asymptote because that'll be a hole. But in this case, nothing cancels. So our horizontal asymptote, to find the horizontal asymptote, we're going to say 7x minus 9 equals 0. So x is equal to 9 over 7. Now this is not a coincidence, okay? Because unless something in the denominator is a whole, it will be a vertical asymptote, unless it cancels out. Now on this one, on g of x, we can find the domain first. Domain, always just, to find the domain, always just set the denominator equal to 0 before you do anything else. That's going to be the domain. It doesn't matter if it's a whole or an asymptote. The domain is going to be determined by the denominator. So I'll say 6x minus 7 cannot equal to 0. So that means 6x cannot equal to 7 and x cannot equal to 7 over 6. So that's part of the domain, and also x plus 20 cannot equal to 0, so x cannot equal to 20. So my domain is x not equal to 7 over 6 and x not equal to 20.
Should that be -20?
Yes, it should be. Thank you. All right, so then I'm going to look for the horizontal asymptote. Now, notice on this one that I've already got some stuff factored. So what you have to ask yourself is, what is the degree in the numerator? X to what power?
1.
Right. What is the degree in the denominator if you multiply the 6x and the x?
And 2.
Yes. So basically here we have a 4x plus blah, blah, blah over a 6x squared, right? So what happens when the degree in the numerator is less than the degree in the denominator? What's the horizontal asymptote?
0.
0. What equals 0?
Y equals 0.
Yes. So that's our horizontal asymptote. So that's what I want you to watch out for, because I think sometimes you might just look at, oh, there's a 4x, there's a 6x. That means that the horizontal asymptote is y equals 4 over 6. But that's not true, because this is already factored. And if you were to multiply that back out, you would get a 6x squared in the bottom. So you do look at that first. I was really trying to make it so that you didn't have to factor as much. Okay, so now I am going to factor everything else. So this would be 4 times x plus 20 over 6x minus 7 times x plus 20, right? And what happens here? What are we going to do here? We're going to cancel out the x plus 20. That means that there would be a hole at -20, but not an asymptote. So where's the only asymptote? It's going to be,
X equals 7/6.
that's right. So if something cancels out, that's not going to be a vertical asymptote. But it will still be not included in the domain. Okay, so I know we're running out of time here, so we're going to just kind of go through these, the rest of these. So here I have f of x equals 3x minus 6 over x plus 5 times x minus 2. Again, what is the degree in the numerator if we're looking for the horizontal asymptote? What's the degree in the numerator? It is first degree, right? And the degree in the denominator would be second degree. So my horizontal asymptote is y equals 0, okay? So remember the rules are, if the degree in the numerator is bigger than the degree in the denominator, then there is no horizontal asymptote. If the degree in the numerator and the degree in the denominator are equal to each other, then you just take that ratio. And if the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is y equals 0. So then the domain, to find the domain, we always just set the factors in the denominator not equal to 0. So our domain is x not equal to -5 and x not equal to 2. And then to find the vertical asymptotes, we'll make sure everything is factored. And the vertical asymptote is determined only by whatever part of the denominator does not cancel out. So that's my vertical asymptote. On this one, the horizontal asymptote, because the degree in the numerator and the degree in the denominator are equal, is going to be y equals to 2/5. The domain is going to be 5x plus 1 is not equal to 0. So x is not equal to -1/5 is the domain. The vertical asymptote, nothing cancels. So the vertical asymptote is just going to be x equals to -1/5. We're almost through. Okay, so to find the inverse, remember you switch the x and y and solve for y. So I'm going to first write it as y equals 1 over x minus 9. Then I'm going to switch the x and the y. And solve for y. So here I add 9 to both sides, so I get 1 over y equals to x plus 9 over 1. Now you could do a cross product and solve for y, or if you have a, let's say you have a over b equals to c over d, that is the same thing as saying that b over a equals to d over c. So we can just, in this case, we can say, since I'm trying to solve for y and y is in the denominator and I want it in the numerator, I can say y over 1 equals 1 over x plus 9. And we could solve that by doing cross product, multiplying through by the lowest common denominator, whatever we want. But if you know this is true, that makes that a little bit easier. So same thing here. Say y equals 1 over x plus 12. So first I write it in terms of y instead of f of x. Then I'm going to switch x and y. Solve for y by subtracting 12 from both sides first. And 1 over y equals x minus 1 over 12 is the same thing as saying y equals 1 over x minus 12. So on this one, it says find g divided by f of x and its exact domain. So g divided by f of x would be g of x divided by f of x. G of x is x minus 8. That's in the numerator. We don't even have to, whenever we're talking about domain, unless there's a square root in the numerator, we don't have to worry about it. And f of x is going to be the square root of 2x plus 6. So there's two things we know about the denominator. First of all, we know that this cannot equal to 0. And secondly, we know that this has to be greater than or equal to 0. So this one right here, if I solve for x, I have 2x is greater than or equal to -6. So x is greater than or equal to -3. But if x is equal to -3, that means that the denominator would equal to 0 and it cannot equal to 0. So the exact domain would be x has to be greater than -3. And you could write it like this or like this, I don't care. So g of f of x means to take the f function, plug it into the g function. So that's going to be the square root of 2x plus 6 minus 8. The domain here is just what's under the radical. We only have to worry about what's under that radical. So what's under the radical is the 2x plus 6. And that has to be greater than or equal to 0. So in this case, x would be greater than or equal to -3. And it's not in the denominator, so it can be 0 very easily, no problems. The inverse of g of x. So the inverse of g of x, say y equals to x minus 8 first, switch the x and the y, x equals to y minus 8, solve for y, y equals to x plus 8. So f of g negative 1 of 7 would be f of g negative 1, 7. Okay, well, we found out that g negative 1 of x is x plus 8. So g negative 1 of 7 is 7 plus 8, which is 11. And then f of 11 would be the square root of 2 times 11 plus 6. 22 plus 6 is the square root of 28. And that will break down if you want all 100% of the, if you'd always want to simplify it, but you would absolutely get the majority of the points if you got it down to this. This would be the square root of 4 times 7, which is 2 times the square root of 7. And I'll finish these out. Here, g divided by f of x would be g of x divided by f of x, which would be x minus 12 over the square root of 5x minus 11. Again, we know that this cannot equal to 0 because it's in the denominator. Because 5x minus 11 is under a radical square root, that means that 5x minus 11 must be greater than or equal to 0. So here that would give me x is greater than or equal to 11 over 5, but it can't be equal to because of that right here. So it's just going to be 11/5 to infinity. G of f of x is the same thing as g of f of x. That tells us to take the f function, plug it into the g function. You always work from the inside out. So that's going to be the square root of 5x minus 11 minus 12. This time, we're only concerned with the radical piece. So 5x minus 11 is greater than or equal to 0. So x would be greater than or equal to 11 over 15. (11 over 5). I don't know where I got a 15. Inverse of g of x. Switch the x and the y. Solve for y. Then this says f of g inverse of 0. We found that g inverse of x is x plus 12. So g inverse of 0 would be 0 plus 12. So f of 12 would be the square root of 5 times 12 minus 11, which is 60 minus 11, which is 49. And that would just be 7. Are there any questions? I know we went through that pretty quickly. We obviously don't have time for the Kahoot. How do y'all feel?
Pretty.
So go back. If I was you guys, I would go back through these problems before you take the test, and I'll post the Kahoot just in case you want to do it for fun as part of your